In this video, I'm going to go over some basic getting started stuff. I'm going to answer some questions, and I'm going to show you some sample sketches, and then we're going to write a sketch from scratch. And so I'm going to go a little bit quick. Feel free to stop and pause it or rewatch it as you need to. And the goal here is just more familiarity. Okay? So before we even get into the code and Arduino and everything like that, when you build a sketch and you want to upload it to the Arduino, you have two buttons right here. This first button is to verify, to make sure there's no visible or mistakes, at least that the editor can detect. And there's this upload option, which will automatically, when you click the upload button, it verifies it anyway and then sends it over. So the verify button is if you want to check it without writing it. If you want to go ahead and write it, you click the upload because it will verify it first and then write it. Okay, if I clicked upload right now, it says error uploading, check if the selected board is currently available. And so I don't have an Arduino plugged into my computer right now, so it won't let me. But when you come in, you're going to have to select a board. So click here and select a board. And the board we're using is the Arduino / Genuino Uno. And hopefully it should just kind of pop up on this window. If it doesn't, you'll have to go ahead and select the board and the port. Okay, and then you can go ahead and run the code. You'll notice that little things, most commonly leaving out a semicolon, will cause for it not to work. Okay, and so you can see that it's red down here because there's an error, and it's actually made a mistake, so it says success, but it wasn't successful because there's errors down here. And so the way that we fix that, though, is we can add the semicolon here, back in, and it should be good to go now. Okay, and so that's the basics of writing it. On our laptops at school, if you were to do all this, you would get an error that it wouldn't be able to write. And the reason why is that for our laptops at school, you need to be logged in not to your personal account, but to this special account here that logs actually into the laptop, like a local account on the laptop. And it's okay if you don't understand what that means, but basically when you turn the laptop on, when you log in, instead of putting your ID and all that, you're going to put this as the username and this is the password. Okay, now an important note is that you need to log out of anything you log into when you're done, because if you don't, it will leave you logged in on that computer. Okay, so like your Arduino Create account, you're going to have to log out of that. If you log into Chrome, you're going to have to log out of that. Anything else, your email, your school loop, make sure you log out of all those things when you're done so that they don't stay logged in. Now, turning the computer off will also log you out on those, but just remember that leaving the computer on and just logged out allows you to turn it on faster. Okay, so the next thing I want to talk about is the comments on the programs. So there's some questions about what the comments do and why they're there. So these comments have kind of several purposes, but they have zero impact on the code. And I'm going to go out on a limb and say that I don't even think when you program the Arduino, I don't think it sends the comments over. It just takes any code, like any functioning code, and it's going to generate some type of, it's going to basically turn into binary, so like zeros and ones, and it's going to send those zeros and ones to the Arduino. And it won't send these things because these things are not part of the program in the sense that they don't impact the function of it. But they are important because of two reasons. First of all, for someone reading your code, if you're writing a code, you put comments in it so that when someone looks at it, they understand what the purpose of doing something is. So for example, it says right here, initialize the digital pin as an output. That's what this comment says. It's referring to the purpose of this line of code. So it's saying reference a certain Arduino pin and say that it's an output. And that's what the purpose of that line is. And so for someone who's unfamiliar or trying to learn or trying to understand what you're doing, this is a helpful tool because they can just read it and you can state exactly why you did something. And so when you're writing a program, it's a good habit to put comments in it for someone else who's reading it. Another really important reason to use comments is for when you are writing a program for yourself. So you're not just doing it for other people, you're doing it for yourself, because when you build a program, maybe you'll write it and then you'll work on something else for a while and you'll come back to it a couple weeks later. Or maybe it's just a really long program with lots of different pieces of code. This is a way for you to kind of keep track of what the different things are for. Because if I were to show you like a really long sketch that I have, let's say, let me find one in my sketchbook here that's pretty long. So this is something that I have that's a pretty long sketch that I'm using for my robotics class, and you can see there is 148 lines of code, which is really not a ton, but it's a lot. And so one thing that is helpful is if I put comments here, if I don't understand what the purpose of something is in that really long program, I can go back and check to see. Okay, I don't have to keep the whole thing memorized. I can write a comment there and say the purpose of this line is for that, so that when I'm looking back through, I remember. Okay, so the next thing I want to go over is some questions that we had about well, first of all, remember that you can customize this if you want it to be a different color. You can, and there's a personalization option. You can change the color. You can change the font size. If you want to make it bigger, make it small. Okay. And so, but the next question regarded, like, what are we doing with this? What can you do with this? And how we're going to use it in our projects. And that's up to you. And remember that I said that in your project, you don't have to use it as part of the product itself, but as part of maybe like advertising it. And so what I'm going to do right now is show you kind of a couple examples of uses for Arduino. So this is like a LED loop where someone made just a sequence of LEDs that flash back and forth. This is something you can do with an Arduino. Okay. Something else you can do, here's some cool projects that someone kind of assembled. So this is an automatic dog feeder where there's a timer probably on the Arduino that they're using to automatically distribute dog food. And then there's like a little water bowl there where there's some kind of sensor that's detecting if there's water in it. And so if it detects there's not enough water, if it's empty, it's going to send water out until it gets to full, and it's going to stop. So this is a great example of how you can take an input of water level and even just a time and use it to control an output, which is sending out the dog food and sending out the water. Okay, this is something kind of cool. Something else that was kind of cool on here, and this is much more advanced, but they're taking an input of the position of this ball and using it to control this platform and keeping the ball at the center. Okay, so this is something someone made to balance a ball. Okay, and this is the point of showing you this is to show you what a wide range of applications the Arduino has, because really the limitation is your imagination. You're still kind of having trouble wrapping your mind around it. A really good way to think of the Arduino is as a compare it to a computer as far as inputs and outputs go. And so if you have a computer, you have generally 3 different kinds of inputs, sometimes 4 depending. You have the keyboard and the mouse, which are 2 basic inputs, and you can input a lot of things with those, the keyboard and the mouse. And then you can sometimes have a speaker, or a microphone rather, and a camera. And those are always to send information in. And then the computer takes those things and makes decisions. Most commonly, you're making decisions from what you do with the mouse or what you do with the keyboard, and then it sends out an output, whether it's showing what you're doing on the screen, whether it's printing out a piece of paper, whether it is playing a sound on the speaker. All of those are examples of outputs. And so Arduino is like a computer in the sense that it can have inputs based on like a sensor to detect distance, a light sensor to detect light, a button detect if you press a button, detect the temperature of something. There's really just, so many different kinds of inputs that you can use, and it's going to control an output such as making a sound go off, making something light up, making something turn on, turning a motor on, anything like that. And it like really, my goal here in these lessons is to kind of give you just a glimpse of the possibilities, and hopefully you'll be able to kind of run with it. So we'll wrap this up really quickly by building a sketch from scratch. So we'll click on the sketchbook. We're going to make a new sketch. Okay, and so you'll notice that there's nothing here except the setup and the loop. These are the two pieces of Arduino code that have to be there. And so what we'll do is we'll make a program to light up an LED. So the first thing we do is we decide what pin we're going to set the LED on, and we're going to take that pin and set it as an output. So it's connected to, say, pin 3, and we'll say pin 3 is an output. Okay, and then we'll say, okay, so with pin 3, let's go ahead and, well, before we do so, the setup runs once, remember. The setup is anything between that brace and that brace right there. And you'll notice that everything that belongs to the setup is tabbed over, and the lines in between end in a semicolon. So within the loop now, we're going to say, okay, so it's connected to pin 3. So we're going to say, we're going to tell pin 3 using this digital write command. We're going to tell it to go to high. Okay, maybe this is a lowercase, no, this is a lowercase d. Okay, and then we're going to wait a second so that we can actually see that it turned on. If we don't wait a second here before we turn it off, then you actually won't even see it turn on. And then we'll write another one, digital write, and now we'll tell it to go to low, pin 3 to low, and this turns it off. Okay, and then we can do delay again. And this is the most basic Arduino sketch, and I'm not going to very often ask you to build something from scratch, but I wanted to give you an example here so you could see it. Some tweaks that we can make. I mentioned that sometimes it's nice to create a variable. So we'll call the LED, we'll say that the LED is connected to pin 3, and we're going to use a word here instead of the number 3 that will allow us to easily change it if we want to move it to a different pin, because we don't have to change it 3 times now, we just have to change it once. We can also make a variable for the delay. We'll call it the wait time or the wait, and we'll set it maybe as 100 to start. So I could put the word wait here, and what that allows me to do is to easily change it up here, but also to do some math with it. So I could say wait equals wait plus 100. And so what that does now is every time we go through the loop, the value of the wait increases. So it's going to start as 100, the next time through goes to 200, then 300, and so on, basically until infinity are turned off. And what that's going to do is make the blinks go slower and slower and slower, which is kind of nice. I mean, you can kind of do some really, this is a really, I will say, a really powerful tool that we can use to do some really cool stuff down the road. Okay, so hopefully this was helpful. Please let me know if you have questions, and it's okay if this is still confusing to you. We're going to keep seeing this over and over, and hopefully it will kind of start to click. Okay,